Alright, we are on the air. Okay, good morning actually, or whatever time it is in your place. My name is Bernardus and welcome back. Today we will be diving deep into my mini web server. Okay, as you can see, I got a new webcam, so it's not right here, but right here because I used to use my phone. Now I have a dedicated webcam of my own. Still no mic, but at least I have a functional webcam now. And if you look at my face, why it's orange, this webcam is quite sensitive to light. It is too dark without my desk lamp, so yeah, bear with it I guess. Okay, so do not expect this server to be something like Express or Flask because I made this in 3 days, alright? 3 days. They are not made in a day, but I made this in 3 days, so it's not yet as good as most micro framework there are. So yeah, as you can see, my issue is completely empty because I focused on coding. Yes, now it's pinned in my account so you can see it. A web micro framework for Java. I'm about to change this description later, and yeah. So as you can see right here, I named my web server Levtus, Levis Conatus, which means or roughly translates to light effort. I built this based on Project Loom, Virtual Thread Java 21, and Semaphore, and I coded this in Java 25. It has no dependency. It has no dependency at all. So as you can see in my pom.xml, boom, it's empty. Yes. So I coded this myself. Okay, as a disclaimer, I didn't code this all myself. Obviously, I use AI, but I can explain how does every single line works from top to bottom, from the front end to the back end. I can explain I can explain everything, alright? So why did I build this? As you can see on the title, it is 2.5-year engineering plan. So this is a part of my 2.5-year engineering plan in which I want to be a better engineer. I want to know everything that happened behind the scene, including networking, socket, and server. So I implemented this without any dependency. So I need to tell agents what to do or code it myself. So this is the technical highlights. It uses Loom native concurrency, virtual thread, which we learned. I use trie-based routing, so each route is like a tree. It branches from the root to many routes, so it can handle something like wildcard and parameter. Parameter doesn't need, but okay. Basically, it can handle wildcard, so you can /use where's my main.id. Yes, you can do something like this, user ID, which I'll showcase later, but for now we'll talk about the justification first. I've explained myself, so let's justification. So 0 dependencies, no DLL and ultra small jar size. Hardened security, I use path traversal, so you can immediately render an HTML using index.html. It must be located inside a public folder, but you can set the static files path into something else. So memory exhaustion, I implemented an API that makes sure that you can limit and basically kind of tweak the engine. As you can see right here, you can change how many concurrent connections can happen, how many empty lines in a reading, how big should the body size be, how much header should the HTTP request have, how many character in a line, yes, how big should a header be, and where's the static files path served. It is tweakable, and when you code this, you'll have the API to change and tweak your own server. So it is customizable and modifiable. And connection overload, yes, connection overload. So based on your max concurrent connection, we have a semaphore right here. Semaphore, yes, semaphore, yes, semaphore. So when it exceeds, when you try to acquire the semaphore, if it fails, the main thread immediately kicks off the incoming request with 503 service unavailable. But if it is accepted, you will pass the task to a virtual thread. So when that virtual thread ends, connection ends, you can immediately serve other people. Yes, this is SSL and TLS ready. As you can see in my security config, I have the get server socket factory, which means that either you provide the path and password to your keystore.p12 files, or not, you'll get the server socket factory as well. So how should I say it? If you pass in your password and path, you become an HTTPS server. But if you not, you'll be just a regular HTTP server. This returns the server socket factory, and since the SSL server socket factory and server socket factory extends each other, if I'm not mistaken, you can do something like this. Let's go back to the engine. This is the parsing method, so it's quite big, as you can see. Now would you look at that? Server socket, we get server socket factory port. So either we'll get the HTTP or HTTPS, the engine doesn't care. It just runs the server socket. It's just run the server socket, yes. And then Fluent API, yes, I took an example from Express.js and quite the go. So as you can see, the API is quite pretty. I designed it so that it'll be like, how should I say it, clear the first time you look at it. You will immediately understand, oh, .use is middleware support, .get means create a simple get route, .get, yes, .post also, .listen means starts the app. When we .create, it returns a Levtus app. So this is the architecture and internals. Connection throttling, yes, virtual thread, I've explained it. Okay, protocol parsing. So as you can see right here, in handle connection, before we pass the request to the router, we parse the request first. So we make sure that the keep alive connection is alive or terminated immediately, bad request. I created my own exceptions right here, as you can see, but I'll explain it later. The first one is we'll parse the header. We'll parse the request line. If it is less than 2, it means that it's bad. We immediately throw new bad request exception. If it passes, we parse the header, and then we check these two first. If the host is null, bad request. If the transfer encoding is not null, it is not implemented yet, so I haven't implemented chunked. It'll be implemented soon, since I plan this to be like mini framework, micro framework. So yes, this is parse the body. I'll explain it later when we'll dive deep into it. Try matching the router tree and middleware execution. Yes, I have implemented middleware here, so you can implement your own middleware and security configurations. So I think this should be pretty lightweight, and yeah, I want to post this into my fan central repository. Quite a big dream, I know, but if it does succeed, I'll notify you guys next week in my Spring Boot time. So now, while we are right here, let's dive deep into the API. This main.java and store, obviously, and public is not on the main GitHub repository because this is what I use for testing. I put it inside .gitignore. So we have main class as usual. Just remember that this is Java 25. We actually don't need it. It is redundant, but for habit and familiarity, I decided to do this. So we only import one line and import one package, and it is actually inside the Levtus package. We import the Levtus class. We create a new Levtus instance with the .create method. .create method returns the new Levtus, and then we immediately start setting things up. Let's get into the Levtus API. Every single one of its, how should I say it? All the variables inside Levtus are private by default, so you need to interact with the set of API that I've written. The first one, as we used, is create. Just remember that the Levtus class is a wrapper around the Levtus engine and router, so you don't need to interact with two classes. Instead, you need to interact with the main Levtus class. So get, post, put, and delete just calls the respective method of the router to add the path to the tree routing, and then SSL means it calls the SSL method of the engine. Set max concurrent connection. This is the security measures I've set. This sets the empty lines, body size, header count, line size, header static files, and then finally we start the engine with .listen method, as you can see right here. So we've covered all the API of the Levtus, so let's get deep into it. So all the variables inside Levtus are only the router and the engine. Each Levtus instances have their own router. And initialing Levtus means that passing the router to the engine, since the engine needs the router as well. So let's dive deep into the router first. We'll ended up in the routing subpackage of Levtus. Before we dive deep into the router, we need to know about the middleware. So the functional interface. Functional interface, if I'm not mistaken, I don't know the correct definition, but the functional interface means it's like acting like a function you can pass, and when you call .handle, it okay, so this is quite complex actually. So okay, let's get back to the Levtus class, and then go to .use, router.use. Yes, when you pass in a middleware type, middleware is a functional interface, which means it's something like the consumer. Yes, it's like a consumer. You create a lambda, functional interface stores the lambda, middleware stores the lambda, and when you call dot handle, you need to pass the ctx and next, so that the middleware can do stuffs with the ctx, and then once the task is finished, you can call next. But if the current middleware block things, you don't go to the next one. So it's like a nesting doll, yes, nesting doll. The middleware is something like that. And node represents a route in the routing tree. So if we take a look at the router, we have the root node. Yes, we have the root node. This is the middleware, right? Copy on write array list. And then we have node right here. It stores all the children, and if you want to use wildcard, you can only use one wildcard card on the same position. So let's say I have /users/wildcard. You cannot have /id while you have the below it /user. No, it's not allowed. And I don't know if I will change this in the future, but I made this in 3 days, alright? Give me some slack, cut me some slack. So then we take the handler, on what to do, the lambda, and then we check if it is wildcard or not. So when you add a new route, so if you see right here, in Levtus, it calls specific methods, right? It calls .get. .get is just a nice wrapper around add route. Add route passes in get, path, and handler. And since handler is something like a lambda or something, yes, lambda, we check the current node. If there's no children, we create a new node, and we split the path that it creates. Split the path. If it is empty, then continue, and if it is a wildcard, we parses it so that we'll get the name, and we'll check if the current wildcard is the null, and the current wildcard name doesn't equal the one you're inputting. You cannot have two wildcards with different names on the same spot. But if it is not this case, then we immediately initialize the current wildcard child with a new node. We change the current into the current.wildcard child, and then we change the name. So this will loop, and loop. And okay, if it is not a wildcard, immediately appends it to the yes. Wait, hold on. Let me read for a second, alright? Compute if absent means if the segment is empty, create a new node. Means access the current children. Wait, hold on. So let's say I pass in and slash. If it is not a wildcard, then we access the current child and passes it to there. and then we pass what it needs to do, right? Okay, we're gonna skip this for now. Okay, let me think for a bit. Oh! Sorry. Hey, sit up. What I'm confused is, okay, I'm gonna be transparent right here, alright? I'm confused right now. So, we access the current. Oh, okay. We immediately change the current to the next node. Okay. So okay, I understand it now. So it loops, right? It creates new. So it becomes a tree /users /new things and then if we have /user /id, so it branches like a tree. And then we have, this is when you add the route. We are not on the handle time, so let's skip that for now. We'll return to the routing method later. So Levtus get .delete. So this is basically only creating the route, yes, and adding middleware. Just creating middleware, and then SSL. Okay, so now we are entering the engine. This is quite entertaining. So we call in the engine SSL method. Okay, so the SSL method takes the path to your keystore.p12 and keystore pass, basically the password to the keystore. SSL, and then after you calls that one, we immediately initialize a new security config, because in Levtus engine the security config is initialized as null. So later we can check, okay, so is this null or not? If it is null, boom, something like that. Where were we again? Okay, so this is the security config. It creates a new security config, which is an object, a record inside security package. It takes the keystore path and keystore pass. We check if it is enabled to check whether this is an HTTP or an HTTPS server. And how to check that, how to change that is this. We first got the server socket factory. Oh, this is when you initialize a server, so we're gonna skip it for now. Later I'll explain it when we get to the HTTP routing, because routing is the big part of this. And then yeah, set next current connection is just setters, so I'm not gonna. So now we're gonna get to the start method. Okay, so now we're entering the HTTP request. First we create the executor service with the new virtual thread per task executor. So this single line is what enables us. Okay, so this single line is what enables us to use the power of virtual thread and handle up to 10,000 concurrent connection. You can change it but depending on your hardware, but yeah. And then we initialize a new server socket with the get server socket factory. The reason this is inside the security config is because it is tightly integrated with the path and pass. We first wrap this in a try catch, yes. We initialize the server socket factory as null first, and we check, okay, is the keystore path and keystore pass not null? If it is not null, then we attempt to initialize the server with the p12 file. So right here, keystore is like what stores the inside of the, how should I say, it stores the binaries of the p12 files. Correct me if I'm wrong, okay? Correct me if I'm wrong. Then we have the password right here. This specifically means stores.p12 files, and then we start a file input stream from the keystore path, and then we load the data into the keystore with the password, and and then we initialize key manager factory. Key manager factory is the one who, okay, think of it something like this. Key store holds the binary data. Key manager factory is the one responsible for translating it into something that SSL context can understand. So key manager factory, we get instance, we get an instance of the key manager factory with the default algorithm of the server. So it's, you can put it anywhere. So, and then we initialize the key manager factory with the data of the p12 file and the password. And then when we create SSL context, if I'm not mistaken, is the one, okay. Instances of this class represent a secure socket protocol implementation. So this acts like a context to say that, okay, this is secure, this is SSL compliant, and let's initialize it. We initialize it with the with a manager. I don't know about the TM, so I'm gonna skip it. And random, the source of randomness for this generator or null. So I create a new secure random, a secure random number generator. Implement, okay, this is the random number generator, so it's safe. And since we are using TLS v1.3, we are on the newest and most secure TLS version. So this is the code. Yes, something like this. We start with 2 numbers. So what I explained last week is this code in practice. It handles the TSL handshake without me needing to like shake the hand of the browser. And when it succeeds, we return the socket server, the server socket factory. We set the server socket factory to a SSL server socket factory. We then throw check exception. You need to pass, if you pass the path but not the password, it'll throw check exception, and vice versa. And if it is null, both are null, then we just give them a normal HTTP server socket factory, and then we return the create server socket. So now we have the server socket factory right now, and then we Levtus engine started on port with the HTTP or HTTPS. And then once the server is running, up and running, we start the new semaphore based on the max concurrent connection. And then while the main thread is not interrupted, we accept a new connection. So the main server is blocking on the dot accept 1 until it reaches a connection. And then once a client connects, we try to acquire the semaphore. If it succeeds, we pass the task to the virtual thread and then handle connection. And once the task is finished, we release the semaphore. Otherwise, the main thread will send overloaded response with the 503 HTTP request, which means service unavailable, connection closed, and the server is overloaded. And because the client is already disconnected, we don't need to do anything about that. Let's go to the handle connection. We pass in the socket to the handle connection, so handle connection can do stuff with it. We have client right here. This makes sure that the socket will be automatically closed when try or catch are finished. Then we create a new buffered input stream with the socket input stream, and the same with output stream. And then this is actually a hard-coded path, so it's bad. I'm gonna change the code right here, so later when I later when I push it to GitHub, I have proof why I did it. So okay, I'm not what did I just say? I'm not gonna change it now. Okay, so I'm gonna decide whether it is better for us to like let the user set the socket timeout themselves or not. But for now, I'm gonna let it sit right here and maybe change it in the v0.2 because this is still 0.1, right? And then we initialized a new response because the response class holds the output, holds the where we can print, and then the static files path. When we initialize the response, when we initialize a new response, we immediately add the type of content type text plain, and we add the server is Levtus v0.1, and then we have a status that returns the object, so that you can chain the whole thing up, yes. And then we have a method that returns content type. We have a add header method that allows you to add headers to your response in main.java, but I haven't used it yet. If I'm not mistaken, it is available on the Levtus context. Oh, not yet. Okay. So I'm gonna fix this one later, but for now we have isEnd to check whether the response has been already sent or not. This is where those HTML render things go. It basically is a quick method, and okay, so we're going too deep, so let's get back. Okay, so we initialize a new response right now, and then we initialize a new request. Request object doesn't mean anything but the incoming HTTP request, so it should be unmodifiable, except when you want to, except we need to know whether the body is cached or not, and how many bytes are read. So we start parsing then we parse the request right here and pass it to request. Parse request throws your exception and you syntax exception. We initialize a new string for each of the request line, and because if I'm not mistaken, on the keep alive HTTP request you have a few blank line before the next HTTP request, so that you don't need to start a new HTTP connection, if I'm not mistaken. So this one right here anticipates the empty lines, hence why we need to set the max empty lines, because if it exceeds that, the hacker can hang a virtual thread forever. So if it passes the max empty lines, we throw a new exception called bad request. If the request line and if the request line is null, we immediately return null, right? And then after all things are checked, we split the request line into 3, and if it is less than 2, it means that it's a bad request. We first text the method first. I don't know why I did it, but first of all, this is needed for the parse the URL later, but for now we parse the header first. We initialize a new string. Why did I use string and list string inside of a new hash map? It is because that an HTTP request can contain many cookie header, if I'm not mistaken. Basically, it can contain many of the same value. So I store it in a list. So while the header is not empty, we first text the header length, and if it passes the size, header too large, and if it passes the count, it is too many. We have too many headers, and after everything is text, we split the header into 2 and trim it. Yes, and trim it, and trim each one. if header's length is 2, and then we pass the trimmed version into the header's list right here. If it doesn't contain host, if it is a bad request, and if it contains transfer encoding, we pass in that, okay, we haven't implemented that yet, we have to reject it. Let me finish. Okay. After the header has been parsed, we have the content length. We have the content length, right? So we can use that to parse the body. If it has more than one content length, it means that it's a bad request, and then we immediately get the real size. We parse the one, and then we check if content length is bigger, yeah, parse. But if the integer parse returns error, just skip because it'll be 0 later. And then we parse the path. Here is where the method earlier come to play. If it starts with HTTP, we trim them, so we only have the domain, right, example.com, and then we check. Okay. So this one checks right here. Does it have the next request like example.com/users? If so, we parse until the example.com, so we have /users. But if no, just starts at the current 0. We already trimmed them, and we check. So if it is equal to / or is empty, we give it a /. But if it doesn't contain a / like example.com, immediately change it to /. So the path is now parsed whether you include the domain HTTP or not. And then here is the new, we parse each parameter. So like !, page equals to what? That's it. Okay, this is getting too long, so I'm gonna skip this one. Okay, first we normalize the URL, the path. We need to fix. So now the HTTP has been gone. We replace every single one of the double slashes with one slash. So until now, you are not allowed to like users / new. No, you will end up in user / new. We normalized it, and then we pass it to the. Okay, so I've forgotten a bit. Why do we need to normalize? Let us search. Why do we normalize path in HTTP request? Okay, so yeah, I remember now. So many security filters look for specific fault without normalization. So yeah, we normalize the path so that the hacker can access our files, like config files. No, we normalized it and we create a new request. We have some that returns null and throw error. If it throws error, it will go to this. If it is an illegal argument exception, it is bad request. And since we have initialized response, we can send it down the drain. And if it is Levtus HTTP exception, okay. So now is the time to explain the exception package. I created a simple runtime exception called Levtus HTTP exception. So every single exception you see right here expands the HTTP exception. So this is just 401 or what. Yes. If it is socket timeout exception, we send request timeout. Exception, it means the server is on fire, right? So then we have the new response. We create the first response to the socket, and for if we found a new request, we create a new response right here, and then we create a context wrapper called Levtus context, and then we set the timeout to 20 seconds for router to handle the path. Now we enter the router, we pass everything to the router. So dot handle method, so this I've already explained this. The dot handle method, it takes the method, it takes the path. We first get the children of the method we requested. So if it is get is different to post. I haven't implemented 405 method to like distinct between, okay, you have 405, okay, you have get but you don't have post. No, I haven't implemented that yet. So yeah, so if it is no, it means the path doesn't exist, and 404 return. We create the path for a new params. We split the request path, and then okay, we've normalized that. We've normalized the path earlier, so now we need to decode it into so that the percentage symbol will be translated. We translate every single segment to uppercase because users should be the same as users with all capitals except for wildcard. So first we check, okay, does the wildcard, does this exist in the children path? If it does exist, go on, continue, set the current children to the upper segment. But if it doesn't exist, we check the wildcard first, and then we put the current wildcard. Okay, params. Okay, we put the wildcard name into segment so later you can access it if I'm not mistaken. Oh, sorry. So later you can yes, you can access the param in the context. You put it into there, and if not, 404 return. So now we have the path in the CTX, and then we perform execute chain current.handler. This one takes the consumer, which if I'm not mistaken, correct me if I'm wrong, it's like a runnable that takes an input, return 0. So basically consumer is a lambda that takes an input. A lambda. Okay, this method actually confuses me before I learned about it. So this method right here is like a Russian nesting doll. No, more like a linked list. So we start with the current final handler. So final handler means what to execute in the router, and then we start looping through the middleware from the last one. So it follows the order in which you add the middleware. We get the middleware and we initialize the next step as current, and then we set the current to the middleware handler. So you can see it right here. So let's say I have the final handler right here. I have a middleware right here. So we initialize the current method with the middleware, and since middleware is a functional interface, okay, I have the CTX and I have the next step, the lambda of the final handler. So when we call current.run, okay, I run, everything is good, go to the next one. The next one is called, it is the final handler. And because the middleware has the privilege to call .next or not, if things go south, you don't need to call the final handler. Yes, that's it. this executes the request, and since current is yes, we return to Levtus engine. Then Levtus engine router.handle is done, and then we check, has the response been sent or not. If it hasn't been sent, then it is 404, and then we check for the keep alive connection, is it cached? Is the request cached yet? Let's go to the isCache method. isCache method, we return that the cache body is null. So because if it has been cached, it means that the body has been read, and we need to skip n bytes. And if it is not, yes, break out of this loop, and finishes the virtual thread task. So that's basically it for my API. Everything else is like a helper function. You can dive deeper into this in my GitHub repository, and my goal is by next week the Levtus version 0.1 will be available for you to install via the Maven Central repository. My target, target can fail, so just wish me luck so that I can post this to Maven Central repository. And yeah, the next section is actually using the router. Okay, so bear with me. For those of you who watched this video until now, it has already been, Lord, it's almost an hour. I'm gonna post a new video after this one, like, how should I say, showcasing the Levtus. So I'm gonna reintroduce myself. Alright, it'll be funny for those who don't understand. So yeah, let's get started. Okay, so good morning actually, or whatever time it is in your place. My name is Bernardus, and today, alright, I'm just gonna this is too weird. Alright, so I have explained everything, dive deep into the Levtus code. You can see it in the video before this, because I should have uploaded this one. Okay, so this is the showcase part. I'm gonna cut. This is a cut version from the original video. So if you wanted to see the full in-depth like surfing, I guess, you can go to the earlier video. So this section will be talking about the usage of Levtus. Levtus is minimalist by default. So you do not have templating engine like TryMyLeaf. You need to set it up, but with the middleware function right here, you can build the library to get on pretty quick. So this is a simple get route, this is a simple get route again, and this is a simple get route again. Let's start the server. After this, I got a picture to draw, a drawing to draw, and a makala to finish. So yeah. Okay, it is HTTP because I haven't provided my password to keystore.p12, I guess. Should I though? I'm gonna delete this. Nah, I'm not gonna risk it. Alright, I'm not gonna risk it. So okay, first of all, okay, I have never used CURL before, so pardon me. Alright, how do I use CURL to do HTTP GET request? Okay. It's not HTTPS yet, so I'm gonna localhost 8080, it should return the dot. Huh? Port number was not a decimal number. 8080 is though. What the? To localhost. Okay. So let's just paste this one. 8080 loh. Okay, so we get the HTML right here. It works perfectly. It works perfectly. And then we have hello from Levtus engine, and then we have user as well, where it returns a JSON file. And then we have the middleware right here. It prints, request receive. You can pen this to your liking, but yeah, it's pretty nice. So now for the final test. Localhost 8080. Boom! It returns the HTML. So that's Levtus for you. It is a simple, minimalist HTTP server built with no dependency at all, as you can see in my pom.xml. Yes. So yeah, I guess that's all for today. I thank you for everyone that has stayed until this 42 minutes hallmark of a video. And yeah, bear with me. Thanks for bearing with me. Thanks for staying with me until now. And next week, we're gonna dive deep into Spring Boot. So, for you all who, so before we close things up, if you find any mistakes in my explanation during this video, feel free to correct me, because this is public learning. I'm not teaching anyone. I'm teaching myself with the help of you guys. So if you guys find any mistake, again, please correct me. Correction and critique are always welcome. So yeah, that's all for today. It's nearly afternoon, so I thank you all for watching. Bernardus signing out.